Too many alerts and not enough action? It's time to get SaltStack. SaltStack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With SaltStack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/SaltStack to learn more. SysDig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using SysDig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. SysDig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using SysDig. To learn more, visit securityweekly.com/SysDig.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. We're currently running two surveys. One is the 5 stages of automation maturity, and the other, our annual listener feedback survey. Please visit securityweekly.com, click the survey tab, and select 5 stages of automation maturity or 2019 listener survey to submit your responses. The new Security Weekly website is officially live. Visit securityweekly.com to check out all of our new sorting and filtering functionality. Please let us know if you find any issues or have any feedback by sending to website@securityweekly.net. Well, guys, I have only one little bug this week to talk about, and it's more of, and I've always resisted trying to use this phrase, but this is going to have to go in the category of why we can't have nice things. It's a small bug in Envoy proxy, and it basically was highlighting that an inconsistency as a callback to our previous segment about how in HTTP 1.1, different clients and different servers handle case sensitivity in HTTP headers or even specifically cookies. So in this case, what Envoy discovered was that they were lowercasing cookie because in HTTP 2, the protocol specifically says you must lowercase convert everything into lowercase, convert a header before you process it. In HTTP 1.1, it just says, do this in a case-insensitive way, and yet not everybody actually does that. It may be capital C in cookie, or maybe it just ignores cookie altogether, cookie if it's all lowercase and things like that. So I mostly wanted to highlight it out of a bit of, it is a little bit of a curiosity and maybe not universally applicable, but I think it speaks to two things. One, if you're creating a protocol, you must be explicit. Ambiguity is an anathema to protocols, as well as having security, bringing into security problems. And two, if you're going to even, a cloud, the CNCF, curating, helping build out something like Envoy, smart people working on modern technology, they're still going to reinvent all of these older problems and nuances that companies building these projects have been doing for the last 20 years. So a little bit of interest there, and hopefully a lesson learned for the developers out there.
So what happens when you convert a Microsoft person to Linux?
Never mind, I'm not going there. What I was going to say is, if you part of the thing around this protocol, we all use the phrase "standing on the shoulders of giants," but as we start using those protocols and sort of trusting them and relying upon them, we sort of become just sort of take them for granted, and we don't think about, is that the right way to do it, or should there be case insensitivity or these type of things. So it's very easy when you have a protocol which sounds simple like HTTP to suddenly become very sort of complex and big, and unless you actually go back and either fuzz this or have lots of users like these guys had that are trying different things to have something like this come up.
Absolutely. It's the idea that standards quite often aren't in the case of HTTP 1.1 in this case. Or talk to, here's an exercise for listeners. Go find out your developers who are dealing with encryption in PKCS 11, especially if they've ever had to use a HSM, and ask them just how standard the implementation is for different for PKCS 11. And I'm sure set aside some time because you're probably going to need a couple of hours. But it's just another interesting conversation to have about how protocols go a bit wrong.
Yeah, go ask your industrial control vendors how RFC compliant they are.
Yeah, exactly. Oh, and speaking of how things can go wrong, I didn't call this out in the breach. I put this more in sort of a learning and tools section, but Imperva had what I thought was a pretty nice and transparent write-up about their breach from October of last year. And in it, they basically say, this is what we did, this is what we discovered over the last year. Here's what happened, and here's how we responded to it. And what I liked pointing out is that what they identified in terms of what went wrong is probably a good exercise that everyone could think of as a pre-mortem, because they probably could pretty easily apply to lots of environments. And so the quick step through was they said they created a database snapshot for testing. This is a database snapshot they had moved into RDS. So they were new users of the cloud at this time, created a database snapshot for testing. They had an internal compute instance that was accessible from the outside world, and this instance had an API key on it. That compute instance was compromised by that, and the AWS API key was stolen, and then that API key was used to access that database snapshot, hence a breach of users' emails, hash passwords, and so on. So, that scenario is actually pretty darn generic. Database that was unsecured, sitting around for a long time, an instance that was thought to be internally accessible only, exposed to the outside world, API key that was a long-lived API key, hadn't been rotated, and then mistakes happened, and it's time for some GDPR notification, get the law enforcement involved, and so on.
Well, I think this goes back to the previous segment we just had with Francois around APIs. We see these, right? How many people knew that API was publicly exposed? First of all, they thought it was internally exposed. They probably didn't know it existed. Then the key got compromised, which now gives you access to this test database that has all this production data in it. And boop, here we are. Very common attack scenario.
Very common, and they listed off 6 things that they were doing, to prevent this. And probably step 0, or is even what you were mentioning there, Matt, is having some API security analysis, because they also, in their first one, it was applying tighter security access controls, and that really just says, "Oops, we didn't realize this was externally accessible." The other one I wanted to call out that I think is really important is decommissioning inactive compute instances, because it's very empowering to say, here is a sandbox for all the developers. Go ahead, spin up all your instances, do what you will. Here's our staging environment, and here's our production environment. But if you're not actually making instances ephemeral, or at least killing them, for outright killing them after a while, you're technically now you're exposing yourself to accruing a lot of tech debt in the cloud, or call it instance debt within your cloud environment. And those instances may just so happen to have that snapshot, that database backup on it, or something like that. That if you had doing something like enforcing instances can't live for more than a week or perhaps a month, that is a great way to narrow that window of exposure. It's also a great way to reinforce the fact that instances getting killed and decommissioned, when they get spun up again, ideally they're getting spun up from that next small iteration of that golden image. So you're applying patches on a very slow but forward-looking progress.
I really like that.
A couple things I would listen.
I'm first, damn it. I really like that phrase, instant debt. I thought that's I really like that one a lot. But you know what? On this blog post, I want to point out something. Just literally the first paragraph, first two paragraph and some bullets on here, is be transparent. They didn't have to do this. They could have shoved this under the rug, but they list off they're trying to do the right thing. They're trying to be fact and data driven, and they want to live up to their company's values and leadership. But I think also there's an aspect of morale inside the company, like, hey, we made a mistake. We've learned from we're doing things. They're allowing people like us to have this conversation about how can we learn from this, and hopefully lots of our listeners and lots of different organizations out there that read this. There's you can try to hide this stuff and shove it underneath the cover and fire somebody or not and do all that type of thing, but having a more mature response to this and actually saying, okay, what's going on? How can we make sure we do this right? I really applaud that, and I wish more people would do it.
Yeah, I mean, we talk a lot on Business Security Weekly about trust and losing trust and keeping trust. And if you want to reestablish trust from a breach, these are the types of things you do, right? You get out in front of it, you acknowledge it early as you can. Then you do the things like this. You actually do a deep dive and you let the customers know, here's what happened, here's the measures we've taken to address it so it doesn't happen in the future. Here's some of the steps you should take. This allows them to reestablish trust with their customers so that they can continue to thrive as a business. And I think this is a very important lesson for anybody who's gone through a breach.
Yeah, I basically just want to reiterate what both of you have said about that idea of building trust and building transparency, so it's more expected that this comes after a breach. Because one of the other aspects of, in addition to building trust, it also helps build it, call it the herd immunity, or it's building the community of lessons learned. Because sure, we could have made that easy hot take and make fun of a web app firewall vendor getting popped. Oh, you didn't have your WAF working. Well, in fact, this was a DevOps scenario that I'm going to guarantee is not uncommon at all in a lot of situations. So it leads to that idea of, here's some mistakes, here's how to avoid them. And then also, we've seen some small steps even with cloud providers like Amazon now being proactive about doing scanning and sending off klaxons when S3 buckets are default public, and switching how they're doing default security configurations for a lot of their environments. And so getting a lot of this push from customers who are burned, admittedly, by their own misconfigurations, by their own missteps, but also not helped by default or fail-safe capabilities within cloud environments. If knowing a lot more of this can, I think, improve things overall. So hopefully we do hear more of it. That does, talking about automation in cloud deployments, there was another article that came across that I saw. It was talking about, basically talking about different ways of thinking about, just rather than just saying we deploy a lot, this concept of progressive delivery. And it's talking a little bit about how to have, building up A/B testing, going into the idea of feature flags and toggles, so that you can roll out code, and the code is sitting in production, but you can slowly turn it on for small populations of users, then generate some logs, generate some monitoring about how that is working on your system, how the impact is on CPU or memory utilization, of course, other types of metrics you have around the health of your system, and then slowly build more confidence to turn on those features more broadly to all of your users. So I don't think this is necessarily anything too particularly, earth-shattering or insightful, but I did want to just highlight it as another way of just a reminder of how to think of this. And I wanted to maybe try to do a little bit of a corrective stance. And when we say, Agile or DevOps mean you can deploy a lot. You can deploy X many times per day. But what does that really mean that you can deploy, 10 times per day? Are you deploying quality code? Are you just deploying a lot of little, spaghetti code, and you're just doing a lot of little iterations without any coherent design behind it? And you're actually accruing a lot of, or are you doing some good refactoring that's actually improving your code for monitoring, so it has better logging? So just one of those things that, rather than strive, I guess this is my point I'm really trying to get to, rather than strive to release early, release often, or even release a lot, figure out why you're releasing so much. And that's not necessarily a bad thing, but make sure it actually aligns with something like security or quality or actually good feature deployment rather than just, yep, we can do things fast. Let's do things even faster.
One of the things I've seen a lot of people sort of stepping over when it comes to, as you increase your deployment rate recently, is retrospectives. After you do a deploy, what worked, what didn't? Did you just change some file for the 10th time in the last 10 releases? If so, why? Is there something? So I think it doesn't take long. It's take a step back, hell, even over like a pizza or something, but think through, what are we doing? Why are we doing it? Are we becoming more efficient? Are our tests becoming better? Are deployments becoming faster? Or are they less issues in our deployment? Like this article talked about waking up the next day to the customers yelling and screaming, right? So it's I think that's the part that a lot of people miss. It doesn't take long. It's just like, I think once you get in the process of stopping and saying, hey, how did we do? I think that can really help things.
Yeah, that's a great point, and it ties in. We've talked a little bit about more like outages, I think, in the past, and having postmortems that are also blame free, because that's been one of the aspects of the DevOps movement, is to say it's not that like, oh, why is Mike releasing code, all the time, and why does he keep doing this that's counterproductive? It's more of, oh, is this because there's no process in place or there's no tooling in place to make this easier? Is it because we're dealing with really brittle code that just becomes more brittle because no one's actually taken a step back to sit around over that pizza and figure out, maybe we should re-architect some aspect of this?
Re-architect. Nice lead into the next article.
Yeah. Yes, I think there is sort of a combination of articles here about what is so the title is Autonomy and the Death of CVEs. And there's also this idea of spaghetti on the wall in the sense of throwing all kinds of different security tools at a problem. And I think these two articles are pretty related. Now, I think the logic might be a little bit off in the first one, talking about CVEs, because it's sort of saying, hey, look at all these fuzzing tools we have. And like Google, for example, Microsoft has been pretty successful with it. But these fuzzing tools create so many bugs that not all of the bugs get CVEs associated with them, because the CVE process is pretty cumbersome. And all the commercial or even open source scanners out there are pretty focused on, we support, these CVE checks, and the PCI, scans are looking for you have to look for these particular types of CVEs. But I think that's a little bit of distraction. And the more important aspect is, what's the tool finding for you? And where are you running this tool to find bugs that need to be fixed? So in the sense of fuzzing, it's really time intensive. And what this article doesn't really capture is that fuzzing does produce a lot of output. And it's not so much you need to sift through and figure out what's a CVE or not. Most of the time, fuzzers are identifying actual crash bugs. So just go fix the bug, it crashed. And then some of the fuzzing that Google has focused on, especially around Android, they actually have then fuzzing paths where they'll identify, is this exploitable, or what is the rough exploitable path and scenario that would be done for this particular bug. And that is really helpful, because that distinguishes between crash bug that's sort of a, yes, we'll prioritize it and get around to fixing it, versus security bug that possibly is an RCE, and therefore we need to prioritize this, roll out a patch within something like a week, if not a few days.
So this article points out some things that some people understand, but some people don't quite understand. And it gets complex when we deal with applications. And we even saw this in the early days of vulnerability management, right? What is a vulnerability? Officially defined, it's a weakness. But we equate a vulnerability to this concept of a missing patch or some sort of remote code execution exploit or something like that. And then we created terms like CCE, common configuration enumeration. Well, misconfiguration is a vulnerability, but we don't treat it the same. We treat it as this concept of a CCE, which kind of died on the vine from MITRE. And then on the application side, we brought in this concept of a weakness, the CWE, and So the article is right in part of this discussion, Mike and John, is that I think the term vulnerability is a little squishy. And because we've got this concept of CVEs, there are certain things that never get classified as a common vulnerability enumeration in the NVD. Right, wrong, or indifferent, it just doesn't exist. But there's a lot of other vulnerabilities that have to be addressed when it comes to configuration of hardware and software and other weaknesses like the OWASP top 10 or the OWASP API top 10 or a whole other set of weaknesses in the application. And all we've done is we made it really weird / difficult to figure out how to bring all this stuff together and figure out of these three different buckets of vulnerabilities, what should we focus on? And I think that's what this article is trying to dig into a little bit. But look, we created this problem ourselves in some respects.
No, that's a great point. Yeah, when we have like, 5 or 6 different things that are common, we're sort of losing the track of, we're either losing track of what the commonality is amongst them, meaning there's lots of overlap, or there's confusing overlap like you were describing. And that I think speaks as well to tools in the sense of what tools should I be using for what purpose? So, you can use your maybe source analysis isn't necessarily going to be the best tool to find misconfigurations because, some tech stacks may be influenced by configuring, a YAML file that changes behavior of how some different services interact, something like that. And of course, if you do have strong application security doing source code review, when you get that deployed into the cloud, you have to revisit how are you handling the service-to-service identity, or what does your IAM story look like in terms of applying least privilege, or even just I'll always go back to the idea of a leaky S3 bucket or Elasticsearch that's open to the world. So that's really important. The way you were explaining that, it really resonated with me in the sense of, are we talking about a vuln, weakness, configuration, and at one point, how much does that particular nuance matter so much as what should we be, we be aligning against in terms of setting up a sort of product security maturity around our system, meaning we have visibility into how many apps we have running, and visibility into our API endpoints, and now we know where they are, we can start monitoring them and logging around them. And so, you're not going to get a CVE that says lack of monitoring. What you're going to do is get that CVE that you have to go dig into your monitoring to figure out how long has it been exploited for, or how long have you been vulnerable to it, that type of thing.
Yeah. And I do like this tools article because I think this is one of the challenges we still have in the AppSec space, right? We're taking some of these old tools, kind of this throw it on the wall and see what sticks. But if you think about your development process and you think about the different stages that code goes through, you can actually align these tools pretty efficiently in that pipeline to create value. And this is where I think the concept of DevSecOps can really come together. And that is looking at some of these tools, like a static analysis tool, right? You do it when you're doing your code and you're checking in that code and you're doing an initial build, right? I can do my software composition analysis when I have that binary that's ready to go. I can also do some level of configuration analysis, move it through to the runtime side where a DAST, an IAST, or a RASP, or a container security product really can give me some insights into what's happening at runtime. But you've got to really think about that entire process and where those integration points are to really maximize these tools. Because one of the articles I was going to put in here, but it didn't really have any meat, was, which tools are effective. This article says, here's the tools you're using, but it's kind of just throw it against the wall and see what sticks. But if you integrate these in the right places, you can actually get more out of those security tools because it's tightly integrated into how code is being built, tested, and deployed. And I think that's where we need to move.
Yeah, and I think what you're really calling out is if you're not bringing these tools into your environment without a strategy behind them about both where they fit within that pipeline and how you're going to use them or what you're going to expect to get out of them, then you're just stacking them up and causing a lot of slowdown and annoyance, and you're losing credibility with the security team in the eyes of the DevOps team. I'm trying to make a little bit of a better metaphor here, but something parallel would be like, oh, why don't we deploy 2 firewalls instead of 1? All you're really doing there is you're increasing your attack surface, because now you actually have 2 services that could either go down, so you need to ensure availability, as well as potentially you have 2 new services that could have some 0-day or some problem in them, without meaningfully increasing the security of your network by just having 2 firewalls in series. So I think this is a similar thing. If you just go about take the approach and say, I need the checklist approach. I need this tool, and this tool, without the idea of this is how the tool hooks in via API into my build system. This is where the software composition analysis says, cool, you're using a outdated library, and Dependabot from GitHub comes in and says, hey, just found this. Here's your PR. All you need to do is +1 it, and everything is fixed. That is a fantastic story, and that's the right story to build, as opposed to just tools that are, mailing PDFs back and forth or manually opening up Jira tickets because you're just trying to close out findings that are coming from these tools without any meaningful strategy behind it.
Exactly. So now you're heading towards. There's a tweet I retweeted on Saturday from Arvind Narayanan, I believe it is. But so he was actually going off on a rant talking about some of the problems with software in the education space. Think like universities and colleges, where the administrators will go and have that checklist. This is what we're looking for our purchase. If we can get 7 out of those 10 checkboxes checked, and we get a good price on it, we should buy it. And then he was comparing that to enterprise software. And those of us on our side of the fence will sort of quickly light up and go, oh yeah, we see that all the time, right? I think about 6 responses down to the thread, someone mentioned one of my least favorite packages here where I'm now, Coupa, which is a finance package for expenses and stuff. And it's very quickly for us to come up with examples. Point being, bringing it back home that, the checklists are nice, but I think it's who's actually writing, reviewing, and authorizing that purchase based off the checklist, right? Every time we go to a conference, someone asks us, are you authorized to purchase and how much, right? It's that guy who's not authorized to purchase, the poor guy who's using the tool every day, who should be actually, me as a startup, when I'm going out building a product, I want to go talk to that guy and say, what are you looking for? And, larger PMs and large orgs should be doing that too. But also, when the purchasers are out there who are listening to us right now, go and talk to that end user, ask them what are they looking for? How did they find this product when it was being demoed? Because you let them run the POC, right? You didn't get the POC and go out to dinner with the sales guy and purchase and just give it to a team. Mm-hmm. So all these type of things come together, and how is that tool being used, as Mike was saying? So it's not just purely for security. It's a pretty common thing, but doesn't mean we can't act on it.
Right. Yeah, we'll have to pull that tweet into the show notes, because it was really cool to see, the company vendor was complaining feature by feature. We beat out all these other vendors. Yeah. We blow them out of the water. But what they discovered is that the user experience was users are just like confused about how to navigate this. It took them 6 steps to do, to get to a very common function that they often needed. And these other tools, it just worked. It made it easy. So yeah, that a great story to build and apply to enterprise software for sure.
Yeah, and Mike, just quickly before we drop, I added another article in here titled "Designing Your First App in Kubernetes: An Overview." If you're a security practitioner and you want to understand how applications are being built and deployed in the modern time, this is a really great blog post actually from Docker that kind of walks you through how to build your first app. And what it's going to highlight for a lot of people is what changes in a containerized Kubernetes-based world that doesn't apply to maybe some of the tools we've already built, and why integration and why some of these things we talk about are so important is because the way we're developing apps is changing. And if the security vendors understood what it takes to develop in this new environment, I think they'll actually build better tools for the developers to keep their code secure. So this was a really good overview article for anybody who wants to understand how these apps are being built.
That's cool. Yeah, I'm going to have to definitely check out that article after this now, because I think it also helps build up that idea of when we were just talking about like vulnerabilities, weaknesses, and even tools, that idea of what are the tools that are specific to checking container security and how does container security impact your application positively or negatively. Essentially, I'm repeating what you were just saying. I'm just trying to add that tool aspect to it to say, here's actually possibly an area that's kind of missing a little bit, or also needs to be figured out that, sure, you're doing source code, you're doing cloud configuration, but does that cloud configuration still take care of your container story and your container deployment, or are there other nuances that you also have to figure out there, including, because you haven't mentioned it so far yet, Matt, don't give up root.
Right. I almost did. I was close.
Okay. Well, I just threw myself off for a good outro for that. So I guess everyone, listeners, thank you for joining us. Come back next week when we have a better outro, and we'll have also another phrase for your bingo cards. I want to say thank you to Matt, thank you to John for a great conversation. Thank you again to Francois for an excellent segment. Check out the one prior to this about API security. And we'll see you next week on Application Security Weekly.